Audible? Hello.
Yes, sir.
Okay, let's start then. Just a minute. We shall start it from the merge short.
Algorithm, sir.
Yes, we shall start with the merge short algorithm. Well, the mechanism has been discussed and algorithm and complexity has to be discussed now.
Yes, sir.
So, as per our discussion, it will be divide and conquer method. It's divide and conquer method. Now, so actually, this will take three steps. Merge short
Yes, sir.
will take three steps. One is divide. The divide step just computes the middle of the subarray. It will compute the middle of the subarray. So here for the divide, n number of elements are there. So here complexity will be big O of n to divide n number of elements. After that, conquer. Conquer means we recursively solved two sub-problems. We recursively solved two problems, each of size n by 2. N by 2 subarray, n by 2 subarray. So time requirement will be, running time requirement will be, time will be 2t of n by 2. 2t of n by 2. This is the time required for conquer because two halves are there. For every half, t of n by 2. This is simple. N by 2 elements, t of n by 2 is the time, and for two halves, 2t n by 2. This is the time requirement. And last step is combine. Combine means we have already noted that the merge procedure on an n element subarray takes time. This one, sorry, theta n. Sorry, theta n. Here this is dividing time, and the same time will be required for combining. It will divide the elements into n number of subarrays. So combining is again will take theta of n. So total time requirement Tn will be either it will be one element or it will be n number of elements, 2t n by 2 plus theta n if n greater than 1, and this is if n is equal to 1. Any confusion? If one element is there, then this conquering is not required because only one element. So conquering time is not required. And if it is greater than 1, if it is 2 also, we have to conquer these two, combine these two.
Okay, sir.
So this is the time. 2t n by 2 for two halves. For one half, n by 2 element, t of n by 2.
Yes, sir.
Now here, this is not our scope. Actually, the master
Sir,
theorem, here we are
sir,
using
plus theta n.
because this one to divide and then conquer. So both
Okay.
time is required.
Both time. Yes, sir.
You will just write down by master theorem because master theorem itself is one huge thing. We will need some more classes to discuss that one, but here we are using that one. We shall show that t of n is theta of n log n. We do not have time to discuss the master theorem, and in your exam also, just whenever you are calculating the will calculate the complexity of merge sort, you can directly write down that by using master theorem, because master theorem does not have to be discussed over there also in exam also. By using master theorem, if we are solving this equation, it will become theta of n log n. So you can directly put this one for merge sort. This will be theta of n log n.
Okay. Sir, can you show the whole thing?
So yes, yes. So in that cases, that means the merge sort here outperforms insertion sort. In insertion sort, the time requirement was big O of n square. Here theta of n log n. This is much lesser than n square. And this is also in worst case, because we are dividing all the elements, all n elements. So this is the worst case. So in worst case also, merge sort is much more efficient than insertion sort or bubble sort, because here complexity is n log n. And in insertion sort or in bubble sort, the worst case algorithm, the complexity was n square, which is much higher than that. So in that way, this can be proved. I just put the total
Sir,
thing into your group. That will be better. I'm just taking one snapshot and
okay, sir.
I shall put this one. That will be easier for you. Just a minute.
Yes, sir, received.
So it's done.
Yes, sir.
So now come to quick sort. This is another one. And remember, whatever we are discussing, we will get one full question from this thing, from sorting itself.
Yes, sir.
Afterwards, we will discuss the searching. We will try to finish up the searching also today. Tomorrow, we have to go for something about graph at least Prince and Kruskal. Now, in case of quick sort, this is also one widely used algorithm developed by CAR Hoare. Actually, this is CAR Hoare. The quick sort has been developed by that. And here also in quick sort we will get big O of n log n, so much lesser than bubble sort and insertion sort. And we have to prove that one. Before that, we have to know the mechanism, how the insertion sort will take place. Suppose we have one array of elements. Here also we are using divide and conquer strategy. How this will be made, we will go for that. Quick sort, divide and conquer. 27, 10, 36, 18, 25, 45. These are the elements, and initially the pointers will be set in that way. This is the location first, and this is left. And here another pointer will be there, right. And remember, first we will point the pointer in the first element and scan the elements from right to left. Scan the element from right to left. And if any element found which is smaller than the left, it will be swapped.
Okay.
So first pointer left over here, and from right is switching from right to left towards left. And here we have found 25 is lesser than 27.
Sir,
So the
40, what about
elements
45? We should not
45 is
compare both.
no, it's larger than 27. So
Okay.
only we will swap whenever any lesser element
Lesser
found.
number. Okay.
So here the item will be 25,
Sir,
10,
CAR means?
36. Sear is the name of that scientist
Okay,
who have
okay,
developed C.A.R. Hoare.
okay. He developed the insertion sort.
No, quick sort. We are discussing about the quick sort.
Okay, sorry, sir.
So 25, 10, 36, 18, 27, 45. So here now right is over here because it switches up to that point, and from left the location comes over here. Location comes over here. Now this pointer will be fixed every time. This will be fixed
Yes, sir.
location, and we will scan the element from left to right. And if we found any larger element than that, it will be swapped. Just the reverse case. If we found any larger element than this one, we will swap.
Sir, can you please once again?
Whatever may be the methodology for this one, for the next step, it will be reverse.
Okay.
Here one pointer was there, here another pointer is there. We are fixing that pointer and we are scanning from right to left. Any
Sir,
item found which is
after
smaller
completing,
than that one,
sir, after completing the first one, we have to proceed for the second one, the
second
opposite one.
pass is in opposite direction.
Okay, sir.
And here the logic is also reverse. If we found any element which is lower than that, it will be swapped.
Okay.
It will be swapped. So what will be the situation next? What
Sir,
will be the situation?
uh, 25.
No, it has actually the pointer is right LOC,
Hmm.
and 25 which is lesser than that, 10 is lesser than that, 36 is higher than that. So this and this will be swapped.
Okay.
25, 10, 27, 18, 36, 45. Now pointer is comes over here. Sorry, 10. Oh, whatever I have changed, nothing. Oh, sorry, 27. This will be fixed always. 27 is the location, so it will be fixed. So in 27, again we will scan from right to left. And any element found which is lower than that will be swapped. So what will be the situation?
25, 10,
25, 10, 18.
27, 18, 27, 18, 27, 36,
Now see,
37.
pointer is on 27. All the elements left of 27 are shorter than 27, and all the elements right to the 27 are higher than 27. So it has been divided into two sub-arrays. Okay.
Mm.
Then you have to start the same methodology, recursive.
Due to
25,
recursive.
10, 18. Yes, we are dividing it into two sub-arrays. Again the same procedure. So in that way this will be continued. So here also the same thing, divide and conquering techniques are there. Here also dividing and conquering techniques are there.
Sir.
Uh,
The first step, the first pass. In the
yes,
first pass, what will be the result? 20, 25, 20, 25, 10, 36, 18, 27, 45.
yes. Because this portion, this we are scanning from right to left and this item is lesser than that. So
So
this
this will,
will be swapped.
okay. After doing the first pass, then second pass. After that,
Again, this is the
the
location.
third one.
Location switches from this point to that point. Now again we'll scan from left to right now.
Okay. In every question, we have to do follow these steps.
In every pass, exactly.
Okay. No, sir. I'm asking that in every problem, we have to first from left, right. We have to start from
Right
right
to
to
left.
left.
Yes, this is the standard. Yes.
After
This
that,
is the standard.
left to right.
No, you can
After
start it
that,
from left. You can start it from left also. Here, if you are pointing the location over here, LOC, and starting the scan from left to right, it will produce the same result.
okay. Anyone,
It
the
will
first
produce
pass
the same result.
or the second
Yes,
pass should be the first,
yes.
and the next will be the second. And after that, we have to proceed for divide and conquer.
Yes. Quick, short, array, pointer, right pointer. Left pointer P, right pointer R. Step 1, if P less than R, then if P less than R means what? At least two items are there. Suppose only one item is there. Suppose this is 27. Here P, this is also R. This is left as well as this is right item. So P less than R means at least two items are there. Then only we will apply the
Quick sort.
quick sort. Yes. Then step 2, we will partition A, P, R. Again, on the third step, we will apply again quick sort recursive.
So if there is only one element, then we should not proceed for quick sort.
This is already sorted. We can't proceed for any kind of sorting.
Okay.
One item means this is already sorted.
Hmm. Okay, sir.
If we have number of elements, this is P, this is R, and it has been sorted in that way, in that way. So this is first P, and this is the Q. So up to that Q minus 1, and this is Q, This is R. So that means first again we will use P to Q minus 1. This will be one subarray and that will be another subarray. So this has been used over here. Because 27 here, 27 is already sorted. This is the qth element. This is q minus 1 and this is q plus 1. So one subarray will be that, another subarray will be that. Sorry, it is 27. Only 36 and 45. Because 27 is already sorted. This is q minus 1, this is q plus 1. So one quick sort will be first element to q minus 1, another quick sort has to be used from A, q plus 1 to R, up to right R. So this is the quick sort algorithm.
Yes, sir. Yes, sir.
Now how the items will be partitioned, we have to go for that. The mechanism has to be written. Partitioning.
Sir, can you get the snapshot? I'll go with.
Partitioning the array. I am coming to that one.
Okay.
Partitioning the subarray. Partitioning procedure. Partitioning procedure actually rearrange the subarrays in place. So our procedure partition A, P, R. Step 1 will be we are taking the value x A of R, right side element. J is equal to P to R minus 1. Already we know that P is the first element up to the right element, right minus 1, because index will start from 0 to n minus 1.
Sir,
Do.
excuse me, sir.
Yes.
So in the algorithm mechanism, the third pass 25, 10, 27, that figure, please.
Hmm.
So the third pass 25, 10, 27.
Hmm.
Sir, can you explain once again, please?
Here the element first where we have changed again come to the first portion. We have already told that this is the P, this is my R, and here location. This is also pointing to the first. We have fixed the location. Here we are not changing anything. We will scan the element and shifting the R towards left. How long it will be shifted? Still the element is not lesser than that. So 45 is higher than that, no problem, no change. Then 25 is lesser than 27. So we are changing that one 25, 10, 36, 18, and here 27. And this location pointer is shifted to that location. And here 45. Now this pointer will be fixed. As I have already told, we will scan the element from left to right. And how long it will continue? Still we are found any lesser element than that. Then it will be swapped. sorry, any higher element than that, because it was lesser, higher element than that. So we are scanning. 25 is lesser than 27, no problem. 10 is lesser than 27, no problem. 36 is higher than 27, we will swap. And this pointer is comes over here. So here, location. Again, we will scan from right to left.
Sir, in the second pass, we have to only do one pass only. In the second pass, we have to go for one step only. No other steps should be continued.
No, just one in every pass, one shifting may be there, maybe. Because if the condition is not, if the array is already sorted, suppose, we don't need any changes.
No, sir. Means I am saying that 25 and the after first step, first pass,
Yes,
25, the result is 25, 10, 36, 18, 27, 45.
yes.
So it is no way sorted like that. That's why I'm asking.
This is not sorted. For that, we are continuing and we are dividing this into two arrays, sub arrays. And in that way, the total array will be divided into 2 by 2 by 2 in that sub array. And these two elements will be sorted and we have to conquer this in like merge sort.
স্যার বাংলাতে বলি একটু
হ্যাঁ হ্যাঁ
স্যার প্রথম স্টেপটা এটা আছে প্রথম পাসটা তারপরে
হুম
একটা পাস করে নিয়েই আমাদেরকে ওটাকেই রাইট লেফট টার্ন করে দিতে হবে আগে
না
রাইট
না
টার্ন
আমরা রাইট থেকে লেফটে স্ক্যান করছি তাতে একটা এলিমেন্ট তো আমার শিফট হয়ে গেছে একটা চেঞ্জ হয়ে
হ্যাঁ
গেল
হ্যাঁ হ্যাঁ
এদিকে এলো এইবারে
আচ্ছা
এখানে আমার কন্ডিশনটা কি ছিল যে কন্ডিশন ইজ দ্যাট here the element should be if it is lesser than any left element it will be swapped সেই জন্যই তো 25টা এখানে swapped হয়েছে 27 এর
হ্যাঁ,
জায়গাতে
ঠিক আছে
25 টা আমার ফিক্সড ছিল the 25 was fixed মানে 27
ঠিক
was
আছে
fixed sorry this
হ্যাঁ
element yes so here now pointer is now pointing on 27 এখানে আমার পয়েন্টার এসে গেছে এবারে আমি লেফট থেকে রাইটে যাচ্ছি এলিমেন্ট গুলো স্ক্যান করতে করতে
স্যার
এবারে ঠিক
ওইটাই
রিভার্স
স্যার ওইটাই জিজ্ঞেস করছি একবারই কেন মানে একবারই করলাম তারপরে ওটা আবার
না আমরা
লেফট
তো কন্টিনিউ করতে করতে যাচ্ছি একই মেথোডোলজি কন্টিনিউ করছি যতক্ষণ না দুটো সাব অ্যারে পাচ্ছি we will continue the method still we are not getting two sub arrays আমরা একটা এলিমেন্ট পেয়েছিলাম এখানে এসে 27 যেটা ফাইনাল পজিশনে এসে গেছিল তাই তো এটা আর চেঞ্জ হতো কি এরপরে আর কোথায় চেঞ্জ হতো এদিকে সবগুলোই লেসার এলিমেন্ট এদিকে সবগুলোই হায়ার এলিমেন্ট তাহলে কোথায় আর চেঞ্জ হতো তার মানে একটা এলিমেন্ট এসে গেছে যেখান থেকে আমি দুটো সাব অ্যারে পেয়েছি মিড এলিমেন্ট আমি পেয়ে গেছি পেয়েছি তো
হ্যাঁ স্যার এই
একটা
স্টেপটা
এলিমেন্ট
বুঝে গেছি স্যার এই
হ্যাঁ
স্টেপটা
তাহলে
বুঝে গেছি কিন্তু
এরপরে তো
ফার্স্ট
আবার এইটুকুর না না এইটুকুর জন্য আবার তো আমাকে ওই মেথডটা ইউজ করতে হবে আর এইটুকুর জন্য আবার ওই মেথডটা
স্যার এটা বুঝে গেছি মানে ডিভাইড এন্ড
হুম
কনকারটা যেখান থেকে হচ্ছে সেখান থেকে বুঝে গেছি
হ্যাঁ
কিন্তু ফার্স্ট
হ্যাঁ
এর থেকে যে সেকেন্ড পাসটা আছে না
হ্যাঁ এখানে
সেইটা
ঠিক আছে
শুধু একবারই করব কেন সেইটাই জিজ্ঞেস করছি
একবার করছি না তো আমরা তো এরপরে আবার করছি ওই সেম প্রসেসটা
না স্যার
এখানে
রাইট টু লেফট গেলাম তো
হ্যাঁ
সেইটা একবারই করলাম
কোথায় একবার
রাইট
করলাম
টু লেফট 25 থেকে 27টা কম্পেয়ার করে নিয়ে যেটা ছিল সেটা শিফট করে দিলাম
কারণ ওইখানেই তো আমি পেয়ে গেছি নাম্বারটা যেটা এর থেকে ছোট ছিল
হ্যাঁ
যেখানেই ছোট পাবো সেখানেই আমাকে ওটাকে শিফট করতে হবে
স্যার আরেকটা কোনো এক্সাম্পল দিবেন আর একটা এক্সাম্পল বাস
হ্যাঁ যে কোনো এলিমেন্ট আমরা নিই না কোনো একটা কিরকম এলিমেন্ট নেবো 5
হুম,
2 10 51 27 32 suppose arbitrarily
হুম,
pointer is over here
yes sir
lock are left and this is right we'll fix that one, and we are scanning from right to left. If any element found which is if any element found which is lesser than that 5, we will swap. 32 is higher than 5, no problem. 27 is higher than 5, no problem. 51 is higher than 5, no problem. 10 is higher than 5, no problem. 2 is lesser than 5. So the next pass will be 2, 5,
5.
10, 51, 27, 32. Now here the pointer is over here, location. And we'll scan from left to right. So here the 2 is
Less
lesser
than
than
5.
5, no change, no change. That means what? All the elements before the left side of 5 is lesser and right side on 5 are higher. So this is one subarray and this is another subarray. Here it's already sorted because only one element. Here again we will use this one is the log, this one is the right, this one is the left, and we'll again use the divide and conquer. It has been divided into two subarrays.
ঠিক আছে স্যার, বুঝলাম বুঝলাম স্যার, বুঝলাম।
So now come to the partitioning part, whatever we are discussing. Partitioning the subarray. Here we have just started writing the algorithm. First x is equal to a of right. Last element we are taking inside a, inside x. A of right. I is equal to p minus 1 means last pointer 0 to n minus 1. For j is equal to p to r minus 1. That means from the first position we are continuing up to r minus 1, last element. We are continuing. Do if a of j is less than is equal to x, that means left item is smaller than right item. Left item is smaller than right item, so we don't have any problem. We will just continue. Then I is equal to I plus 1. We are continuing from left to right. জাস্ট রিভার্স লজিক যেটা বলেছিলাম তার উল্টোটা ইউজ করেছি এখানে, সেই জন্য এই জন্যই করলাম এখন, যাতে দিস উইল বি ক্লিয়ার দ্যাট from any direction I can move. This is fixed. We are scanning from left to right first. No problem. Here
ঠিক।
this is smaller. We will go to the next pointer I plus 1. Otherwise, if it is false, then exchange.
স্যার যদি ওটা বড় হয় তো, ফার্স্ট
ওই তো
এলিমেন্ট,
তাহলে এলসে চলে এলো, দিস স্টেপে চলে এলো।
তখন স্ট্র্যাপিং করতে হবে।
হ্যাঁ, এক্সচেঞ্জ। ওকে
স্যার এক মিনিট।
আর ঠিক এর রিভার্স কেসটা, এর উল্টো কেসটা কি হতো? এক্সচেঞ্জ এ অফ জে প্লাস 1 এ অফ আর, রাইট সাইড থেকে position will be returned.
স্যার যখনই শুরু
Fifth
হবে
step.
তখনই যদি রাইট থেকে লেফট যাই তখন লেফটেরটাতেই পয়েন্টার থাকবে সবচেয়ে লেফটের ফার্স্ট এলিমেন্টটাতেই।
ইয়েস, সেইভাবেই তো সেট করলাম।
আচ্ছা
এই তো এখানে
ঠিক
তাই
আছে।
হয়েছে,
হ্যাঁ স্যার,
এ অফ আর। হ্যাঁ,
হ্যাঁ।
So now this is the partitioning. Now we have to calculate the complexity. Same thing. We are dividing the array into n by 2 elements. Again, n by 2 will be divided into n by 4 elements in that way. So Tn, like the previous one, is equal to T of n by 2 plus T of n by 2 plus theta n. Already we have done that one on the previous. Same thing is equal to 2T n by 2 plus theta n. So actually already we have done that one. Tn is equal to theta of n log n. N log n. Same thing like previous one, quick sort. Sorry, merge sort. The same, because here also we are using divide and conquer technique. We are using divide and conquer technique.
Yes, sir.
Now in worst case, the situation will be different. In worst case, the situation will be different. Why? Because in worst case, the array will be reversely sorted. The array will be in reverse sorted order. So in that cases, what will be the situation? Tell me. Everywhere the changes will be there, everywhere the swapping will be there in every position, isn't it? Because this is reversely sorted. Just take one example. If it is reversely sorted, 50, 45, 23, 10, 5, 2. So here I am putting the element here left, here right, here location.
Yes,
So
sir.
this will be changed. This will be changed. Again, every location will be changed. So
Okay.
here first
Two,
scan from
two,
right to left. This will be compared and it will be changed.
two will go in the place of 50, and 50 will come to
Yes,
2.
yes. Now here that means first one comparison plus 2 second element plus 3 plus etc. up to n comparisons. Is it okay?
1 plus 2. So 1 plus 2 plus 3 means?
First here it will be changed
Yes, sir.
50.
Uh,
2 will comes over here.
okay.
Then this will be the pointer. We will scan from right to left.
Uh,
Again here this will be compared, this 2 and 5.
it's
So it
okay.
will not
5
be
is greater.
changed.
Uh,
Then next, yes, then the next will be changed.
all are greater than 2. Therefore,
Yes,
no
yes, yes,
change.
yes. Exactly. So it will be n into n minus 1 by 2 is equal to big O of big theta of n square. Already we have done it. So if it is reversely sorted, then the complexity will same as that of bubble sort or insertion sort. So this is the worst case. This is the worst case.
And the first one, Tn, is the best case.
This one is the average case. Best
Okay.
case I am coming. Best case, in case of best case,
Okay.
in case of best case, no exchanges will be there. Are you agreed?
Best
Means
case.
if the array is already
Ah,
sorted. If the
time
array is
limit
already
is
sorted,
already.
yes. So this part will not be required.
Uh,
Okay.
yes, sir.
So only 2t n by 2.
So in the
This is
means
for the exchange.
so in the worst case, time should be greater, and
Obviously.
and the best case
Obviously,
time should not be
should be
20
the
minutes time
minimum.
minimum.
Should be the minimum. Should be the minimum time. If it is already sorted,
Hmm.
no exchanges will be there. No swapping will be there. So this
Okay.
will take minimum time.
And in average case, sir?
Average case, this one, some
In
exchanges will be there. Some exchanges. I don't know how many exchanges. This will be depend on number of elements.
okay.
Sir,
Yes.
so what it is written in the average case, Tn will be equal to theta of n log.
No, this is not the best case. This is
No, sir, that is the
Average case.
average case. What it is written? Theta of n log n or what?
which one? In case of best case,
Average case,
Average
what is?
case.
No, sir, average case. What is it written?
average case is that one 2t n by 2 plus theta of n.
No, sir, he asking that why it is written theta is n log n.
Oh, sorry, n
Theta of
log n.
n log n.
Yes, sir.
No, this is by using master theorem. Already I have told that one because the one derivation will be there. This is huge derivation. The master theorem, we have not discussed that one. This is not in your syllabus also. Here we have just used that master theorem to calculate that one. Otherwise, we have to go for this total master theorem and we have to calculate that one. How from this expression, how do we get theta of n log n? This
Hmm.
has to be discussed. But here, this is not in your syllabus and you don't have to discuss in the exams also. So what's
Okay.
the requirement for going for this huge
Okay.
extractions and all these things? Because we do not have time. Otherwise, I will discuss this thing in the class. We have only one class left tomorrow. And this is not in the syllabus also. Nowhere this will be there in your question that describe master theorem or like that.
Okay, sir.
So this is okay. Now sorting, I don't think any other sortings are required in according to your question paper. Maybe you go for quick sort, but this has to be checked whether question. You should check the question paper whether quick sort was there or not. If
Sir,
this is
sir,
there, we will discuss. Yes.
sir. In this question, that 50, 45, 23, 10, 5, 2, we have to from swap the 2 and 50.
Which one?
This
Here.
question. Yes, sir.
Yes. Yes. On the first position, because right side all the large elements will be there. Left side all the small elements will be there.
After that, sir, after that, 5 and 2 should be compared.
After that, just go as per our rule.
Yes, sir.
So
5 and
what
2
will be
should
the
be compared.
situation of the array? Just draw the situation 2, 45,
23,
23,
10, 5, 50.
10, 5, 50. And my pointer is on here.
2.
Yes. So now this value we have scanned from left to right, and
Yes.
here 2 will be compared from left to right, but
Yes.
this is the leftmost element, already lesser. So rest of the array has to be sorted.
Okay.
45, 23, 10, 5, 50. Again the same method, and this will be exchanged, this will be same, this will be same, this will be same, this will be same. So this element has been sorted. Now come to 45, 23. In that way, this will be continued. So here what?
স্যার একবার এটা কমপ্লিট
Here,
করে দিন না।
just a minute. One, two, we are comparing with that.
হুম,
Again, here 50, and here this is 2. Here this is 2, and here 50. We are comparing with all the elements. We are comparing with all the elements. So that means what? 2 has been compared with all the other elements. That means here comparison is like that. Actually, এটা আমার উল্টো দিকে লেখা উচিত ছিল, এটা উল্টো দিকে হবে। n minus 1 plus n minus 2 in that way comparisons. N minus 3, etc. up to 1. So the same thing, n into n minus 1 by 2.
স্যার এটাকে একবার কমপ্লিট করে দিন না, এই টুটা, টু এর কোশ্চেনটা পুরোটা একটু কমপ্লিট করে দিন না, একটা খালি।
এটা
হ্যাঁ হ্যাঁ স্যার।
এটা কি অসুবিধা? এটা তো করছিলাম। কি এলিমেন্ট ছিল?
স্যার 2 45 23
2
45
45
23
23
10
10
5 50 बस।
ফার্স্ট 2 ছিল, তাহলে তো কোনো চেঞ্জেস নেই। কেন থাকবে? ফার্স্ট 50 ছিল।
আচ্ছা
So here 2 comes 45 23 10 5 50. Pointer is over here, and here no left element, so this has been already sorted. Then that means 2 is out of the array now. 45 23 10 5 50.
স্যার 5টাও তো 2 এর থেকে একটু বড়, আর বাকিগুলোর থেকে ছোট।
না, আমরা কি করি, এখানে পয়েন্টারটা এসেছে, আমার নেক্সটটা কি ছিল, লেফট থেকে রাইটে স্ক্যানিং ছিল, কিন্তু এর লেফট, এটাই তো লেফট মোস্ট এলিমেন্ট, এর আর লেফট কি? তাহলে 2 অলরেডি সর্টেড হয়ে গেছে।
ঠিক আছে স্যার। তারপরে
দেন আগেন
স্যার
এইখান থেকে আবার সেম থিং,
স্যার স্যার স্যার
দিস ইজ লার্জার দেন দ্যাট, নো চেঞ্জ।
স্যার যখন রাইট থেকে লেফট যাব তখন 2 আর 50 কে কম্পেয়ার করলাম,
হ্যাঁ,
তারপরে
ওখানেই চেঞ্জ
5
হয়ে গেল,
হ্যাঁ ওখানে চেঞ্জ হয়ে গেল, তবে 5
ওখানেই
কে
চেঞ্জ হয়ে
কম্পেয়ার
গেল।
করব না?
না, আমি সেই পর্যন্ত যাব কেন, আমার তো পয়েন্টারটা শিফট করে চলে এসেছে এখানে তখন, এই যে,
তো
তারপর আমি 5 এর সাথে এখন করবো কেন?
তো
না, এরপরে তো আমার
রাইট টু
লেফট থেকে
লেফট
রাইটে।
একবারই যাবে, রাইট টু লেফট
হ্যাঁ,
একবারই যাবে।
একবার কেন, সেটা ওই পজিশনে ছিল বলে, আমাকে কেউ বলে দেয়নি একবার নিতে হবে। আমার যদি 2টা এখানে থাকতো তাহলে আমি এখানেই চেঞ্জ করতাম, এই পর্যন্ত স্ক্যান করে করে আসতাম।
স্যার মানে ও যেটা বুঝতে পারছে না, মানে এলিমেন্টটা লেফটে এলে লেফটটাকে স্ক্যান করবো না, রাইটটাকে স্ক্যান করবো, এরকম ব্যাপার হচ্ছে, সেটাই তো।
হুম।
আর এলিমেন্টটা রাইটে মানে সোয়াপ করার পরে আর কি।
স্যার আমি বলতে চাইছি যেমন উম, এটা 50 আর 2 কে করলাম, তারপরে 2টা বাঁ দিকে চলে এলো, তারপরে
আমার পয়েন্টারটাও তো 2 তে এসে গেছে, তার আর লেফটে কোনো এলিমেন্ট নেই, তাহলে আমি লেফট থেকে রাইটে যাব কি করে?
আর যদি স্যার 50টা 10 এর জায়গায় থাকতো তো?
50 যদি 10 এর জায়গায় থাকতো,
হ্যাঁ
থাকলো, আমাদের যেমন রুল সেইভাবেই হবে। এখানে
10
10 ছিল, এখানে 45 ছিল, এখানে 23 ছিল, এখানে 50 ছিল, এখানে 5 ছিল, এখানে 2
2
ছিল, এরকম
হ্যাঁ
না, এখানে
হ্যাঁ
2
স্যার,
ছিল।
না স্যার
আচ্ছা,
বাঁ
ওখানে
দিকে,
ঠিক
বাঁ
আছে,
দিকে 10 থাকবে।
এখানে রয়েছে, এখানে রয়েছে পয়েন্টার।
হুম
প্রথমে এখানে আমার ফিক্সড, এদিক থেকে স্ক্যান করছি,
হুম
তাহলে আমার 2 হুইচ ইজ লেসার দেন দ্যাট, আমার শিফট করে গেল এখানে
2 এসে গেল এবার।
45 23, যেমন সেরকমই এখানে 10 এসে গেল, এখানে পয়েন্টার। এবার আর লেফটে কিছু এলিমেন্ট নেই, তাহলে এটা আমার সাব অ্যারে হয়ে গেল। 2 আমার অলরেডি শর্ট হয়ে গেছে, 45 23 50 5 10, এটার উপরে আমি লেফট নেবো, আবার রাইট নেবো। রাইট, এখানে আমার এটা ফিক্স, এদিক থেকে স্ক্যান করছি, যদি কিছু বড় পাই তাহলে 50-তে এসে বড় পেলাম, তাহলে 50 বড়, কোনো অসুবিধা নেই। সরি, যেটা ছোট পাবো 45-এর থেকে ছোট পাবো সেটা শিফট করব। তাহলে 10 এলো, 23 এলো, 50 এলো, 5 এলো, 45 এলো। এবার পয়েন্টার এসে গেছে এখানে। নাও স্ক্যান রাইট টু লেফট হয়েছে, এবার লেফট টু রাইট হবে। লেফট টু রাইট আর হবে না, 10 আবার শর্টেড হয়ে গেছে, কারণ লেফট মোস্ট এলিমেন্ট হয়ে গেছে। এবার আমার সাবারে হবে এটা 23, 50, 5, 45। এখানে পয়েন্টার, এখানে পয়েন্টার। 23, 45 larger, কোনো প্রবলেম নেই। 5 is lesser, so 5 will be shifted. 5, 50, 23, 45. Now pointer is 23. We are scanning from left to right. 50 is higher, so shifting will be there. 5, 23, 50, 45. 23 is the pointer. So now 23 left এ সবগুলো shorted, right এ সবগুলো larger. Now 50 and 45 will be changed. In that way,
ঠিক আছে স্যার।
স্যার 5টাকে কি করবো?
5টা আপনি
5
কেটে
তো
দেবেন।
শর্টেড রয়ে গেছে, শর্ট হয়ে গেছে তো ওটা। এবারে মার্জ করতে হবে আমাকে। 5 একটা এলিমেন্ট পড়েছিল এখানে, এর আগে কি পড়েছিল, 10 পড়েছিল, এর আগে পড়েছিল
2টা।
2। তাহলে এটা একটা, এবারে আমরা সেই মার্জ শর্ট করব, 5 আর 45 কম্পেয়ার হবে, আর থার্ড আর এতে সেইভাবে যাবে। সিম্পল। হয়েছে? ক্লিয়ার?
হ্যাঁ স্যার, ক্লিয়ার হয়ে গেছে।
Now come to the searching part. Two searching methodologies are there. You know already, I think one is linear search, another is binary search. So,
স্যার ওই
did you know
পেজগুলো
the,
একটু,
হ্যাঁ,
ওই পেজগুলো একটু স্ন্যাপশট।
আমি একটা, আচ্ছা ঠিক আছে দিয়ে দিচ্ছি। Now, in linear search or binary search, did you know the mechanism?
নো স্যার।
No. let's start it. For linear search, it's very simple. Whatever searching methodology you have already used, we are using that searching methodology. Suppose linear search means I have elements, suppose, so let's say for example one array of elements 10, 8, 2, 7, 3, 4, arbitrarily I am taking 7, 3, 4, 9, 1, 6, 5. Now suppose I am going to search value 7 has to be searched. The normal methodology, simple methodology will be what? We will start from the beginning. We'll start from the beginning and we'll compare. If it is equal, then the item has been searched, it has found. Otherwise, we'll go to the next element, in that way up to last element. Sorry. And if the item is not there, the search will be failed and item is not present. So here what will be the maximum number of comparisons? N number of comparisons. Is it not?
Yes, sir.
Maximum n number of last element, suppose. So we are comparing n number of elements. So here complexity will be big of n. And how the algorithm will be there? First initialize. Set position is equal to -1. Step 2. Initialize set y is equal to 1. Repeat. Step 4 while y less than is equal to n. That means I am continuing up to last element. Step 4 if a of I is equal to value. That means we got that value. Set position is equal to I, then print position, go to step, we need go to step. What will be the step? We will write down later on. End of if set I is equal to I plus 1, end of loop, step 5 if position is equal to -1, means no items are there, found, print value is not present, end of if, step 6 exit, go to step 6 here. This will be the algorithm. I am just posting it, it will be better.
Yes, sir.
So this is the complexity big of n, and this is the algorithm for linear search, because we are following some linear methodology. We are continuing from the first element till the last
Sir,
element.
can you will you please explain the algorithm once?
So first, you got that one, no?
Yes, I got that.
So first position is equal to -1 means pos value is one variable pos. This is
Hmm.
initialized to -1, nothing.
Hmm.
Now set I is equal to 1 means we are starting from the first element.
Hmm.
And we are continuing while I less than n means we will continue up to the last element, from first element to the last element. I less than is equal to n up to last element. Now if a of I means array element on the first position is equal to value, that means position is equal to 1 I, and we will print the position item. We got that item. Otherwise we will continue with I plus 1. We will go to the next element, again it will be compared if a of I is equal to value, in that way. So if we got the element inside the array, then value of position will not be -1, it will be something else. But we are comparing now. If it is -1 means item is not there inside the array, and the value of pos is remain there at -1. It has not been changed. So item has not been found. Item is not present.
স্যার মাঝের ইয়েটা প্রিন্ট
কোনটা?
পিওএস আর তারপরে
হ্যাঁ,
প্রিন্ট
তো আমরা পেয়ে গেলে ওখানে প্রিন্ট করে দিলাম যে আইটেমটা আমরা পেয়ে গেছি, করে আমরা এক্সিটে চলে এলাম, বেরিয়ে গেলাম প্রোগ্রাম থেকে, আমাদের তো পেয়ে গেছি আমরা আইটেম।
আচ্ছা
যদি না পাই তবেই আমরা পরের এলিমেন্টে যাব, i is equal to I plus 1।
স্যার এর মেকানিজমটা
মেকানিজমটা তো কিছু নেই, আমরা এখান থেকে সার্চ করছি 7, we are searching for 7. First I is equal to 1, it will compare with 10, item has not been found, I is equal to I plus 1, পরেরটাতে এলাম। Again we are comparing this is equal or not. If this is not equal, we are going to the next item. We are going to the next item, and it has been found. So the index will be displayed 1, 2, 3, 4. The position 4 has been displayed. We found that item. Otherwise, again we will continue. Or if item is there, we will exit from that location, because
সিম্পল
we got
সার্চিং
the
করব
item and exit. Simple searching. Linear search means simple search.
ঠিক আছে ঠিক আছে
Normal searching methodology is the linear search. Binary search is something different. We will discuss it in tomorrow.
ওকে
Linear search is the normal searching methodology.
ঠিক আছে
So only these much students are there. I think. What about the all other students? They are not joining. What's the problem? Why they are not joining? Anyways, tomorrow's class is on 7 p.m. Try to
স্যার
join over there, and we'll continue a bit tomorrow up to 8:15 or like that. We'll try
স্যার
to finish up this one. Yes.
morning no class is there
Now only this will be the last. I will post that one in the group.
ওকে
Most
স্যার
probably this will be the last class. Tomorrow only one class is there for this
Okay.
subject. Okay. Okay. Chalo. Good night.
স্যার what
Thank
will you
you.
teach tomorrow
We'll
So
continue that
timing will be
binary search. Binary search has to be completed fast. Then we'll go for the graph algorithms. Let's see how much has been completed.
okay
so what will be the timing?
Time 7 p.m. 7 p.m. I'll post it in the
Okay.
group.
okay sir Good night, sir.
Okay, sir.